This is Mission Control Houston at a mission elapsed time of 8 days, 17 hours, 51 minutes into the flight of Integrity on the Artemis II mission. The astronauts were awakened aboard Integrity about an hour ago. They're in their post-sleep period, reviewing morning messages, getting a bite to eat, completing the stowage of items in their crew cabin. As everything is all set, the stage is set for their return to Earth this evening, with a splashdown of the Pacific off the coast of San Diego 7 hours and 40 minutes from now. Here in the flight control room, known as the White Flight Control Room, a shift handover has been completed. The entry team of flight controllers now on duty, led by Flight Director Rick Henfling. Henfling has trained with this team for more than 2 years for this day. He will be joined on console by spacecraft communicator Jackie Mahaffey. Astronaut Stan Love also will be by her side as a second set of eyes as Integrity barrels home, completing a mission that will have spanned 694,481 miles from launch to splashdown. In the shift handover, no significant issues were reported. The vehicle is in great shape, and the weather at the splashdown zone couldn't be better. Winds are forecast to be 10 knots at splashdown, wave heights less than 4 feet, and the wave periodics against the capsule as it bobs in the Pacific Ocean about 17 seconds. We are expecting a few broken and scattered clouds, but that is not an issue. Integrity is coming home through the law of orbital mechanics. The next major milestone for Integrity's astronauts and the flight control team here in Houston will be the RTC-3 burn. That is the return trajectory correction number 3 burn. That is scheduled 2 hours and 25 minutes from now at 1:53 p.m. Central Time. It's an 8-second firing of the reaction control system jets to essentially fine-tune the path of Integrity down the corridor for its entry into the Earth's atmosphere. There will be a change in velocity of 4.2 feet per second. That is the last major maneuver of the mission. The crew will continue to configure the crew cabin. They'll climb into their launch and entry suits later today and move into their entry checklist. So this is a good time for us to run down all of the key milestones and all of the key numbers that you'll be hearing reported as we move into the final phase of this 9-day mission. Following the RTC-3 burn and the crew climbing into their launch and entry suits, we will have NASA Plus coverage joining in a simulcast of our 24/7 YouTube coverage at 5:30 p.m. Central Time, 6:30 p.m. Eastern Time. At 6:15 p.m., Integrity will switch communications loops and the strings for communication from the Deep Space Network, which it has been on since the translunar injection burn the day after launch. We will transition from the Deep Space Network to the Tracking and Data Relay Satellite System. At 6:33 p.m., the crew module and its 4 astronauts will separate from the European Service Module. And at 6:37 p.m. Central Time, these are all Central Time, we will conduct about a 19-second raise burn. Now, if you think of yourself sitting in a recliner and tilting backward, this raise burn gently raises the aft end of the vehicle. It is our last opportunity to dial in a flight path angle before entry interface using the roll thrusters on the crew module. This will sweeten the angle of attack, if you will, the orientation of the vehicle as it enters the Earth's atmosphere, with the idea in mind of reducing any excessive heat stress on the heat shield in this deliberate opportunity that we have selected to try to mitigate any buildup of excessive heat on the aft end of the vehicle. Once the raise burn is complete, we will enter the first traces of Earth's atmosphere at 6:53 and 31 seconds p.m. Central Time. At that point, we'll be at an altitude of 400,000 feet, traveling 34,882 feet per second, with a range to splashdown of 1,701 nautical miles. Just 24 seconds after entry interface, traveling at that velocity, we will begin a 6-minute blackout period due to the ionization, the buildup of plasma around the spacecraft that will prevent communications and data from being received here in Mission Control. Again, that blackout scheduled to begin at 6:53 and 55 seconds p.m. Central Time, about a 6-minute blackout. We'll be carefully monitoring a call from Capcom to the crew as we exit the blackout. That will be our first communications with the crew following that 6-minute period. The blackout scheduled to end right around 7 p.m. straight up. That's Central Time. That'll be 6 minutes and 25 seconds after the start of the entry interface. At that point, we will be at an altitude of 157,406 feet off the Earth, traveling at 13,342 feet per second. Range to splashdown at that point will be just 147 nautical miles. There will be a series of roll reversals, this is computer commanded, to roll the vehicle to the left and back to the right to bleed off excess energy, all part of the planned entry profile for Integrity and its 4 astronauts. We are expected to go subsonic, meaning we will break the sound barrier over the Pacific in this trajectory that will carry us from southwest and northeast across the Pacific Ocean. We will go subsonic at 7:02 and 25 seconds p.m. Central Time at an altitude of 59,000 feet, traveling just 971 feet per second. So you can see how much the velocity of Integrity will decelerate based on its speed and the interaction with the Earth's friction in the atmosphere. At that point, a series of parachutes will begin to deploy. The first deployment will be the forward bay cover chutes. These are a series of 3 parachutes, each parachute approximately 100 feet long. The first forward bay cover parachute deployment will occur at an altitude of 24,000 feet. As the spacecraft has descended to a velocity of just 479 feet per second, and we will be within a mile, 1 nautical mile of splashdown at that point. In rapid fire succession then, we'll deploy 2 drogue parachutes used to slow and stabilize the crew module during descent to establish the proper conditions for main parachute deployment that will follow. A trio of pilot parachutes then deploy. They'll be used to lift and deploy the main parachutes from the forward bay of the crew module. That's the top portion of the crew module. And finally, 3 large main parachutes will deploy. The main chutes are scheduled to deploy at 7:04 and 44 seconds p.m. Central Time at an altitude of just 5,400 feet from splashdown. The velocity for the astronauts aboard Integrity at the time of splashdown expected to be just 19 miles an hour. So in just 13 and a half minutes from the start of entry interface to splashdown, we will have decelerated from what is expected to be a peak velocity of some 23,783 miles an hour to just 19 miles an hour for a gentle splashdown. One of the important points that we've been explaining and that we'll be looking for later today is the comparison between the entry for Artemis I, which was uncrewed, and today's entry for the Artemis II astronauts. On Artemis I, we had an entry range of 3,178 nautical miles, and we used what was called a skip entry profile, where we dipped into the atmosphere, then dipped out, and then dipped back in. That lasted about 20 minutes for entry, and it induced a higher total heat load on the vehicle. Now, on Artemis I, we flew that trajectory, and as part of the routine post-flight inspections and video analysis, there were areas of mechanical char liberation that were observed, which was not expected. As we explained yesterday, it's worth explaining again today, and we'll do later today as well. The chemical decomposition of ablative heat shields is fully expected. The mechanical liberation of the char was not expected. The chemical decomposition occurs as the heat shield material heats up and decomposes, the process called pyrolysis, which generates gases during entry. The generation rate of that gas is a function of the temperature of the heat shield material, which is known as avcoat. As the gases are being generated, a layer of char is forming on the surface of the heat shield. That char is porous. Now, ideally, what you want to have happen is for the gases to escape through the pores in the char layer faster than new gas is generated. But on Artemis I, we found that the temperature profile experienced by the heat shield and on the heat shield was such that this was not happening on areas of the heat shield with less porous avcoat. That resulted in a pressure buildup under the surface of the char layer, and when the pressure gets high enough, the portions of the char layer would liberate from the heat shield. That's what we observed. As a result of all of this, NASA gathered experts from across the agency and private industry, including establishing an independent review team to investigate this issue, and after extensive analysis, everyone agreed with the conclusion that we should plan to fly a shorter entry trajectory to avoid a temperature profile conducive to high rates of gas generation as that avcoat chemically decomposes. Now, for Artemis III and beyond, we're redesigning the heat shield, different heat shield, and redesigning the manufacturing process such that we will have material that starts out more porous and will allow a more efficient gas dissipation as that char layer forms, which will be a critical feature for a longer duration skip entry trajectories returning from the south pole of the moon. The bottom line of all of this is today, instead of a 3,178 nautical mile entry range, we're targeting a 1,701 max entry range to our splashdown zone off the coast of San Diego, 1,701 nautical miles. We're using a lofted entry profile. That's being done through the raised burn. The duration of the entry is about 14 minutes rather than 20 minutes, and that induces a much lower heat load on the heat shield to allow it to do its job to maximum efficiency. Following splashdown, which again is scheduled at 7:07:07 p.m. Central Time. That's 7:07 and 7 seconds p.m. Central Time, 5:07 p.m. Pacific Time, 2.5 hours before sunset at the splashdown site. Following splashdown, we will get a call from the crew. The communications will transition to what you'll hear called VLDR. That's the acronym for Very Low Data Rate, because we no longer have the antennas pointing toward the Tracking and Data Relay satellite system at that point. Now, whether the vehicle is upright in the so-called Stable 1 configuration, or whether it's upside down in Stable 2, we will quickly activate the CMOOS system, the acronym for the Crew Module Uprighting System. The Crew Module Uprighting System consists of 5 large balloon-like airbags located under the capsule's forward bay cover. These airbags will be inflated with helium, providing additional buoyancy to flip the capsule upright if it's in Stable 2, or to maintain it in a Stable 1 configuration. Navy helicopters, Navy paradivers, a Navy flight surgeon and a NASA flight surgeon will all be on the scene and will be erecting a large raft called a front porch alongside the spacecraft. That is similar to what you've seen in the movies and in the past in historic footage from the Apollo missions. That will be utilized once the hatch is open to allow the crew members to be extracted one by one onto that front porch before they're hoisted onto a pair of hovering Navy helicopters in sequential fashion and alternating fashion as well for the short ride back to the deck of the recovery ship, the USS John Murtha. Now, before we get into all that, it will take about 15 minutes to power down the vehicle, and for flight controllers here in Houston and the Navy recovery team to ascertain that there are no toxic gases that are leaking from Integrity. We do not expect that to happen, but they'll put eyeballs on it to match the data that we will see here at Mission Control to ensure that the recovery team can make a safe approach to the spacecraft to begin the process of erecting the front porch. The current order of extraction from the vehicle that we received from the ship called for Christina Koch to be extracted first, followed by Victor Glover, then Jeremy Hansen, and then Reid Wiseman last. The hoisting of the crew members to these two helos, Christina Koch is scheduled to be hoisted first into helicopter number 1, or the helicopter A as it is being termed by the recovery team. Jeremy Hansen would be second to be hoisted. He'll go into helo number 2. Victor Glover will be hoisted third and will go into helo 1 to join Cook. And Reid Wiseman will be hoisted into helo 2 to join Jeremy Hansen for the ride back to the ship. The recovery position would put the ship about 2,000 yards away from the spacecraft, assuming an on-target splashdown. The small boats will be much closer so that they can be deployed in rapid fire succession to arrive at the side of Integrity to ensure that they begin the orderly process of erecting the front porch and beginning the process of opening the hatch. The John P. Murtha, the recovery ship, is expected to be about 5 miles away from the spacecraft at the time of splashdown. That will expedite the helo flight for the two helicopters back to the deck of the ship. Once on the ship, the crew will emerge from the helos and they'll be brought into the medical bay on the ship for comprehensive medical exams that will set the stage for them to be flown off the ship at a subsequent hour. We just don't know exactly what that hour will be at this point. It will depend on the condition of the crew and other factors. But once they depart the ship, they'll be flown by helicopter to the San Diego Naval Air Station to board a NASA plane to fly back to the Johnson Space Center in Houston. So that's your snapshot rundown of the activities that lie ahead. The next major activity, just over 2 hours from now, that will be the RTC-3 burn, the return trajectory correction burn number 3, the final in the series of fine-tuning maneuvers to pinpoint Integrity's precise path down the middle of the corridor for entry into the Earth's atmosphere. This is Mission Control Houston. This computer-generated visualization based on real-time telemetry from Integrity showing the distance from Earth decreasing with each passing second, now just 54,000 miles from Earth, and the distance traveled by Integrity's astronauts since they arrived at the Moon earlier this week. We are currently 7 hours, 10 minutes away from splashdown, a high-speed entry back into the Earth's atmosphere, awaiting Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen to wrap up a mission that will have logged from launch to splashdown 694,481 miles. That, of course, includes that high Earth orbit that carried Integrity to an altitude at apogee of about 43,000 miles above the Earth for the first 24 hours of the mission to enable flight controllers to ring out all of the systems on Integrity and collect data that gave them the confidence to give approval for the translunar injection burn that sent the crew on its way to the Moon and an historic flyby of the lunar surface. This is Mission Control Houston. 8 days, 18 hours, 39 minutes into the flight of Integrity on the Artemis II mission. Here in the flight control room, Flight Director Rick Henfling and his team of entry flight controllers on duty, joined by spacecraft communicator Jackie Mahaffey. That's the voice you'll hear talking to the crew throughout the course of the day's activities through entry and through splashdown. Aboard Integrity, the astronauts, Commander Reid Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen are wrapping up their post-sleep period, having an opportunity to review their morning mail, getting a bite to eat, and getting things set up for final cabin stowage of items no longer needed on this flight prior to the time they move into their entry checklist a few hours from now. The next major milestone will be 1 hour, 38 minutes from now. That will be the firing of the reaction control system thrusters on Integrity in what is called the RTC-3 burn, the return trajectory correction number 3 burn, the final in the series of mid-course correction maneuvers to fine-tune Integrity's path so that it reaches the center of the entry corridor at the orientation we want the vehicle in, as it approaches and enters the Earth's atmosphere at an altitude of 400,000 feet later today. This will be an 8-second burn to change the velocity of Integrity by 4.2 feet per second. And again, will be the final major maneuver of this mission. After we discard the European service module, this evening at 6:33 p.m. Central Time, a few minutes later, we'll conduct a raise burn, as it is called. That is a maneuver using Integrity's thrusters, about a 19-second burn that will lift the aft end of the vehicle and provide the final angle of attack that the spacecraft will be traveling in to reach the splashdown zone some 1,701 nautical miles from the point of entry interface. In the Pacific Ocean, the USS John P. Murtha is on station, ready to begin recovery operations once Integrity has splashed down. The splashdown is scheduled at 7:07 and 7 seconds p.m. Central Time, 5:07 p.m. Pacific Time, 2.5 hours before sunset. From launch to splashdown, Integrity and its 4 crew members will have traveled 694,481 miles. Communication with the crew on the voice loops will pick up considerably in the next short period of time here as we move out of the post-sleep period into the final hours of the cabin configuration, the preparations for the return trajectory correction burn, and then the crew moving into its entry checklist. All of Integrity's systems are in excellent shape. The latest weather forecast from the Spaceflight Meteorology Group here at the Johnson Space Center for the splashdown zone southwest of San Diego calls for winds at about 10 knots, wave heights less than 4 feet, wave periods, that's the periodic raise and subsidence of the waves against the spacecraft, that should be about 17 seconds in duration. Just some broken and scattered clouds expected in the splashdown area. The weather is go, the vehicle is go, and we are set for splashdown 6 hours, 48 minutes, and 50 seconds from now. This is Mission Control Houston.
and routing procedure.
We can get started on the while.
All right, that was all we had for you for cabin entry config for now.
Houston, speaking of cabin config, one thing for you, the contingency urine or CWC, that a plan so that we could actually complete that stowage as a get-ahead last night, and that's been done. We did not use a hefty bag, but it is empty and it is sealed in 2 Ziplocs inside the JSB. We feel that it's unaccessible now, and we'd like to keep it in that config.
All right, Christina, thanks for the status. We will confirm that is a good config.
by the recovery personnel that will be deployed from the USS John Murtha, which is on station out in the Pacific in the splashdown area. The weather forecast for splashdown is ideal. Winds just about 10 knots, wave heights less than 4 feet. Those are very benign conditions that will await Integrity's astronauts when they emerge from the spacecraft. Following splashdown, the 5 crew module uprighting system airbags will be inflated with helium to ensure that the spacecraft remains in an upright and rather benign situation as it bobs in the Pacific Ocean. This will expedite part of today's entry. Will begin.
Integrity Houston, some pre-burn SA for you. The plus X flange heaters are on and prop avionics are configured.
Okay, we copy, Jackie.
Jeremy Hansen from the Canadian Space Agency acknowledging the call from Capcom Jackie Mahaffey. It is her voice that you'll be hearing throughout entry and splashdown, calling all the major milestones and talking to the crew when required. The heart of today's activities will begin about 5.5 hours.
Got safety protocols? Grainger has the Safety Pros 2 call. Shop our vast